minterm is nothing but it is product of all the literals, and as I told you, here we are considering the value of the variable is x equals to 1, that is minterm. If n equals to 3 and 2 to the power of 3, that is equals to 8. So the K-map will be having 8 squared. There are 4 variables. 2 variables we have written here y and z. Another 2 variables here, not w and not x. Dear students, welcome to Computer Science Revision classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us continue our discussion with the chapter Boolean Algebra. So in this session, we are going to talk about the simplification of Boolean expression using Karnaugh map. So now we have learned in the previous session what are Boolean expressions. So next one is how to simplify Boolean expression. So one of the method is by using, we say Karnaugh map, or simply in short is a K-map. So let us see what is a K-map. So it is a K-map is named after its originator, the Mr. Karnaugh, M. Karnaugh. These maps are sometimes also called as witch diagram. So another name of K-map is witch diagram. And it is a Karnaugh map or K-map it is a graphical display of the fundamental product in truth table. So this is another method of displaying or representing fundamental product of truth values or truth table. And it is nothing but a rectangle. K-map is a rectangle made up of certain number of squares. Each square representing a max term or min term. So this is a definition of a K-map. What is a K-map? K-map, another name is called witch map, and it is a graphical display of fundamental product in a truth table, and it consists of a rectangular boxes and made up of certain number of squares. It depends on number of variables, and each square represent either min term or max term. So this is the definition of K-map. Next one is for how to draw a K-map. So next one is to draw a K-map. See, for a function of n variables. So for a function of n variables, we can have 2 to the power of n squares, as we have seen in the previous slide. So this K-map consists of number of squares, and this squares depends on the number of variables in Boolean equation. So here 2 to the power of n squares, and each representing min term. Now we are considering the example of min term simplification of K-map, that is SOP form. So here given a K-map for SOP, sum of product form, SOP for reduction, the map is filled by placing in squares whose min term led to one output. So what you have learned in our previous session, we know what is a min term and max term. What is a min term? Min term is nothing but it is product of all the literals, and as I told you, here we are considering the value of the variable is x equals to 1, that is min term. That is the meaning of the sentence where leads to a one output. And please notice that the numbering scheme here is 0, 1, 3, 2. It is not 0, 1, 2, 3. It is 3, 2 and 4, 5, 7, 6. And again it goes on like this. So this one you have to be very careful while writing or numbering in the squares in K-map. And the binary code 0001 is called gray code. This is a gray code, and it is the binary code in which each successive number differs only in one place. Now that is why numbering scheme follows in the above order. So here, if we want to draw a K-map, first we should know number of variables in a K-map. If for n variables, we can have 2 to the power of n squares. For example, if there are 2 variables, n equals to 2, we can have 2 to the power of n, that is 2 to the power of 2, that is equals to 4. So the K-map will be having 4 squares. Similarly, if it is n equal to 3, that is 2 to the power of 3, that is equal to 8, we can have 8 square K-map. And if there are 4 number of variables, that is n equal to 4, 2 to the power of 4, that is equal to 16. So K map will be having 16 squares. So that is the meaning of the sentence here. If n variables, then we can have a 2 to the power of n squares. And we have to consider, because we are simplifying of SOP reduction form, so in that we are considering min-term. So value of variable x, that is non-board letter, is equals to 1. And the number in scheme is 0, 1, 3, 2. It is not 0, 1, 2, 3. And these are called gray codes. So this is how to draw number of squares depending on number of variables in the Boolean equation. Now let us see, it is how to draw two variable K map. If there are two variables, so that is n equal to 2. So 2 to the power of 2 is 4. We can have 4 squares. This is how to draw squares, 4 squares. And numbering scheme, as I told you, it is 0, 1, 2, 3. It is 0, 1, 2, 3 in this two variable K map. And here, this is important, 0, 1, 2, 3. And here, because here the value of 0, 1, 0, 1. If you consider 0, here it will be 0, comma 0. So 0, 0. So in min-term form, value there are two, one is x and is one y here. If we go to 0, it is x naught, because as I told you just now, in min-term form, value of variable x equals to 1. So if x equal to 1, so if it is x naught is equals to 0. Accordingly, 0 stands for 0, 0 in binary, and if you consider it is 0, 1 and it is 1, 0 and 1, 1. So means we have converted these numbers, this 0, 1, 2, 3 into decimal. So 0 decimal number, in binary it is 0. So this is binary code or binary number, and this is in decimal number system. So 0, and for 1 it is 0, 1, and 2 it is 1, 0, and for 3 it is 1, 1. So accordingly, we have to map like this. Then after this, now we can start writing the variables. How to write the variables? There are two variables, one for this and one for this. So here it is 0 means x naught and 0 means here y naught. And again it is 0 means x naught and here is y. Why? Because y stands for 1. Non-board letter is 1. See, this is how to draw variables for given number of variables in K map. So this is how to draw variables. First step is to draw squares, number of squares, by looking at number of variables. Then we have to numbering scheme. We have to follow the numbering scheme, or we have to number the squares here. After that, we have to write the variables according to this numbers or numbers. And here this 0, 0, 0, 1, 1, 0, 1, 1 are called gray codes. So this is how to draw a two variable K map. Next one is for three variable K map. For three variable, that is n equal to 3, 2 to the power of 3. Here, if n equals to 3 and 2 to the power of 3, that is equals to 8. So the K map will be having 8 squares. See, this are all 8 squares, how we write in K map. And here observe this. Number scheme 0, 1, it is 3, 2, it is not 2, 3. And again 4, 5, 6, 7, it is 6 here, 7 here. It is 7, 6, not 6, 7 in the order. And after writing this, we have to write the variables. So here, as we have seen in the previous slide, this 0 stands for 0, 0, 0. There are three variables because it is a three variable K map. So one variable is here, another two variables are here. For 0, it is x naught, and for 0, y naught and z naught, because we are considering the min-term expression. So it is SOP form of reduction. So this is 0. Similarly for this is x here and y naught, z naught here. So this is how first we have to draw number of squares, then we have to number it according to the K map. Then we have to write the variables accordingly by looking at the numbers in the squares. So this is the second step. First step is to draw K map. Then we have to write the variables for both and x and y, z are variables. So this is how it looks like. See, this is a three variable K-map. Similarly, in 4 variable K-map, so that is if n equals to 4, that is number of variables equal to 4, that is 2 to the power of n, that is 2 to the power of 4, that is equals 16. So K-map will be having 16 squares. And as usual, numbering scheme 0, 1, 3, 2, 4, 5, 7, 6, and observe that here 8, 9, 11, 10. So then 12, 13, 14, here 15, then 14. See, this is how to number in 4 variable K-map. Then after this, we have to write the variables on both x and y axis or for both variables. There are 4 variables, 2 variables we have written here y and z, another 2 variables here not w and not x. And this, as I told you in the previous slides, so by looking at this number, we have to write the variables. So this is 12. Here example 0, 1, 3, 2 are decimal numbers. We have to convert this into binary. Then after writing binary, they are called gray codes. By looking at those values, we have to write the variables here with or without bar. So this is important part of K-map, and this is how it looks like. So this is 4 variable K-map. Here please observe that numbering scheme is important, and also writing variables is also very important. Next one is, now we have written, we know how to write K-map. Next one is how to map in K-map. Next concept is how to map in K-map or how to fill this K-map. So what are the values to be filled in K-map? So depends on given equation or given Boolean equation. So in this example, f is a function equal to sigma. Here sigma stands for, it is SOP form of reduction, that is sum of product form using K-map. So reduction of Boolean equation, that is SOP equation by using K-map or Karnaugh map. And here sigma stands for it. And in this example, they have given variables a and b. So we have to draw 2 variable K-map. See, this is that variable K-map. Next, we have to write the variable for this. And here, what is mapping or what value you have to write here? Now we know the number here 0, 1, 2, 3. So accordingly, so here first step is 2. It stands for the number in squares. So in this example 0, 1, 2, 3. 2 is here. We have to write 1 here. Why we are writing 1 here? Because we are considering in SOP form, that is min term small m, the value of x equals to 1. So in this value of x equal to 1, we have to fill the K-map with the number 1 here. So this is represents the min term value. So here accordingly this is 1 and second number is 3. So with this here the code is 3. We have to write 1 here. So after this, next one is for unfilled boxes. For remaining boxes, it has to be filled with 0. So this is how to map in K-map or how to write the values inside the K-map. You have to be very careful. Once if you write this, if you leave it as it is wrong. So we have to complete this with 0. This is how to map in K-map is an example for 2 variable K-map. Now look at the example here now. For example, sigma 0, 4, 14, 15. Now consider this example now. Here this is a K-map with 4 variables, and in this example, if you observe this, these are the variables, these are the numbers. Now by looking at the equation, we have 0, 4, 14, 15. So where 0 is the number here, we have to mark with this 1. This is 0. Next one is 4. Next we have to mark with 1, 4. And 14 is here. And next one is 15 is here. So we have to mark these squares with 1 because it represents min term expression, min term value. So for other boxes or other square has to be filled with 0. So this is a right method of mapping in K-map. Now consider one more example here. So if you look at another example here, again in this 4 variable K-map, so after writing the numbers in the squares and again the variables, look at the equation here 0, 4, 6, 7, 8, 12, 15, 16. For all these numbers in the squares, we have to mark it 1. So here 0, 4, 6, 7, 0, 4 and 6, 7 and again 8. 8 is here, 12, 15 and 16. So we have to mark these squares with 1. And again for others we have to fill this K-map with 0. So this is how to map in K-map for 4 variable K-map. In the next slide, it is product of sum reduction using K-map. So far in the previous slide, we have seen the reduction of K-map, that is SOP form, it is sum of product form. So next one is another form of reduction is product of sum reduction form using K-map. So this is another form of reducing Boolean equation. So accordingly, look at the example of this, and here this is when I talk about POS form, that is product of sum. We are considering here max term. We are considering the max term. Max term we represent with capital letter M and value of the variable equals to 0. Here we consider value of x equal to 0. Means in the min-term form we used to consider value of max term m equals to or x equals to 1, but here it is x equal to 0, stand for non-borrowed letter it is 0. So this is related with the product of sum, it is reduction by we are representing by using max term form. So accordingly, first step is to draw K-map for number of variables, for 2 variables or 3 variables and 4 variables. So this is an example for 3 variable K-map representing max term, means reduction of product of sum form. So here now we know that how to write the numbers, number of squares and how to write the variables. Now here please understand this. Here the difference is numbers in the squares remain same, but only the writing variables are different. This is product of the sum. So accordingly, observe this. This is x and it is y plus z naught, y naught plus z naught, y z naught. And here x and x naught. Please observe the difference between the SOP form of K variable and POS form of K map are variables. And here one is min term, one is max term. So in SOP form, this is sum of the products, and POS form, it is product of the sum. So accordingly, here we have y plus z naught, and as you know that these numbers, this is the decimal number. If you convert this, it will be in binary. It stands for again 0, 0, 0. As it is the product of the sum, we are using plus in between. And here, this x represents the one value. As I told you, the value of the variable of x equal to 0 in POS form or max term form. Accordingly, it has to be write the x here. And this is y plus z. So this is product of sum form. This is how to write variables for POS form of K-map. This is 3 variable K-map. And similarly, this is again K-map for 4 variable K-map. Now this is numbering scheme remains same. This is 0, 1, 3, 2, 4, 5, 7, 6, 8, 9, 11, 10, 12, 13, 15 and 14. So accordingly, we have tried the variables. Here, please observe the variables here. It is 2 variables, w and x comes here, y and z are here, and this is y plus z and it is y plus x. Here there is a plus in between, and here also plus in between. And again, 0 stands for 0 plus 0 plus 0 plus 0. Here in max term, value of variable equal to 0. We have to write here, because it is a 0 here, it should be only w plus x. So this is how to write variables in POS form of K-map. So this is 4 variable K-map. Next one is how to reduce expression in SOP form using K-map. See, so far what you have learned is we know what is a K-map, how to draw a K-map, how to map in K-map, then how to write variables. And we know after that, now how to simplify the given K-map of Boolean equation. So here, for reducing the expression, First one is, as the first step, we have to draw the K-map. It depends on variables, 2, 3 or 4 variable K-map. Next one is map in K-map. Then after that, we have to mark pairs, quads and octets. So first we have to make a group of pairs or quads or octet. You know what is a pair? Here pairs are nothing but in SOP form where there is a two continuous one or the two ones are next to each other. So this is either horizontal or in vertical position. And quad stands for 4. If there are continuous one, it stands for 4. Again, it is either horizontal or in vertical position. Similarly, octet stands for 8. So if it is possible to have continuous 8 ones, so it forms one octet. So after mapping in K-map, we have to make the variables, or we have to start making the groups, either a pair, quads and octet. And also we have to consider map rolling, overlapping groups and redundant groups. So by considering all these things, we have to make a groups like this. So after that, by looking at the K-map, it is possible to remove number of variables accordingly. So here, if you look into that, the pair always removes one variables from the equation, quad removes two variables, and octet removes three variables. So it is possible to remove the variables for simplification. Then after removing variables accordingly with different groups, we have to finally write all the variables together as the final simplified expression. So this is a procedure to simplify K-map, simplify the Boolean equation using K-map. It is of SOP form, sum of product form. Students, now let us take this example. It is simplification of SOP form of expression using K-map. Now consider this example. Function f of ABCD equals sigma. These are the values. And here, first we know how to draw a K-map. The 4 variables, you have to draw 4 variable K-map with 16 squares. Then numbering scheme 0, 1, 2, 3, 4, 5, 6, 7. And here 8, 9, 10, 11 and 12, 13, 14, 15 here. Then after this, next step is we have to map in K-map. So according to these numbers, we have to map the values here, 7, 9, 10 accordingly. See, this is 7, again 9, and again 10, 11, 12, 13, 14 and 15. So we have to map, this is called mapping in K-map. Then for others, we have to fill other squares with zeros. So this is a complete K-map, and by looking at this, we know how to write even variables also. Next step is how to solve it. So as usually, we have to go for grouping here. So if you look at this example here, first we look for octet for 8 continuous ones, either vertical or horizontal. So but here in this example, we cannot find 8 continuous ones, so we cannot have octet. Then next one we have to look for quad here. So if you look at this example, here 1, 2, 3, 4, there is a continuous one, it forms one quad. So we can group this as one quad. So after that, again if you consider this, so here these 4 ones, 13, 15, 11 and 9, it forms one quad. And again, we are left with these 2 ones. So thus we can have one more quad here. So 15, 14, 11 and 10. It forms one more quad. Then we are left with one more one here. So this one, we can have one pair with this 7 and 15. So this is how we are grouping in this example. So accordingly here, we could able to find 3 quads and 1 pair. So let us write this statement. So equation, so we have to say first Q1, first quad. In the first quad, we have 13, 15 and 14. We have to say here M is for midterm. So it is M12 plus M13 plus M15 plus M14. So this is one quad. So next we'll mark again second quad 2. In quad 2, we consider these 4 ones, 13, 15, 11 and 9. So we can write here M 13, M 15 plus M9 and M11. M9 plus M11. So we can mark a second quad. Again, one more quad, that is quad 3. Quad 3 is 15, 14, 11 and 10. So we can write here M15 plus M14 plus M11 and M10. So these are 3 quads. Again, we have to write one more pair here, 7 and 15. So next we can write here pair. Only one pair we can say, or we can write pair 1. So here pair 1 is M7 and M15. So here we can write M7 plus M15. So here after mapping in K-map, next one is we have to write the groups here, or we have to mark the group in K-map. Then we have to write accordingly the corresponding min-term variables. So after this, next one is simplification. As all of you know that in a pair reduction, it removes one variable, quad removes 2 variables, and the octet removes 3 variables. So here, by looking at this, now let us try to simplify this. So here Q1, now consider in this row 12, 13, 15, 14, and if you observe this, so here we have continuous ones here. In continuous ones, so the variable A and B remains same. So we will write AB, variable AB as it is, and if you consider this AB, now consider the variables C and D. In this example here, C0, D0, C0, D, here D is changing its states. Again, if you consider this, again C is changing its from C0 to C. So because of that, we have to remove 2 variables C and D. So we are left with the variables AB. This is after reduction of a quad, we are left with variables A and B. Now similarly, simplify the second quad, that is 13, 15, 11 and 9. Because in this example, here there are 2 ones here correspond to these columns, and these 2 ones correspond to this row. So we have to consider rows as well as column. Now you consider the rows here. If you consider these here, these 2 variables here, A is remain same and B is changing from B to B0. So we have to eliminate or have to remove the variable B. So we are left with variable A in these 2 rows. Similarly, consider these 2 columns. So if you observe this, here C0 is changing its states, so that has to be removed. So we are left with the variable D. So this is after reduction of second quad, we are left with the variable A, D. Similarly, let us look for one more quad here, that is 15, 14, 11 and 10. Again, we have to consider these 2 rows and these 2 columns. So when you consider these 2 rows, we are left with B is changing its states. So we are left with the variables A, and again, if you consider these 2 columns, in these 2 columns, CD and here C, D0. So D is changing its states from D to D0. So that variable has to be eliminated. So we are left with the variable C. So this is AC. This is the result of simplification of the quad M15, 14, M10 and M11. Next, we have to simplify the pair 1 here. So once you consider this pair here, so in this example, CD, it remains same. So CD remains same here, no change. Now consider 1 here and 1 is here. We have to consider these 2 rows here. If we consider these 2 rows, A0 is changing from A0 to A. So we have to eliminate variable A. we are left with variable b. So that is variable b. So this is after reducing the quad and pair. These are the variables we have got it. These are the next. Finally, we have to write all the minterm expressions together to get the final simplified form of SOP form of the Boolean equation. So finally, we have to write f equals all the expression, that is a b plus, and this is ad, and this is ac, and next one is bcd. So plus bcd. So this is the final expression. So this is how to reduce the given Boolean equation of SOP form through or using K-map. And here in this example, to draw K-map and mapping in K-map with the corresponding variables, it carried 2 marks, and here another simplification, it carries 2 marks, and this final result, it carries 1 mark. So this is a very important question from examination point of view. Students, now let us continue our discussion in my next session. Thank you very much.